2-point charges, Q1, which is 3 microcoulomb, and Q2, which is minus 4 microcoulomb, are separated by a distance of 0.2 meters. Calculate the electrical field at a point P located 0.1 meter to the right of Q1 on the x-axis. If a small positive 1 Newton per coulomb is placed at point P, what force does it experience due to the electric field? Before I can start calculating, I'm going to determine the direction of the electric field at point P. First, I look at the point P relative to Q1. Q1 is positively charged. Q1 is positively charged, and the point charge is positively charged. Therefore, positive and positive will repel each other. So the direction of the electric field, according to Q1, will be to the right. That is towards Q2. Now, due to Q2, the electric field at P due to Q2. Q2 is negatively charged and the point charge is positively charged. Unlike charges attract. So due to Q2, the direction of the electric field will be also to the right. That is towards Q. So both are towards Q. So I expected my net electric field to be towards Q. Now let's start calculating. Calculate the electric field at point P, located 0.1 meter to the right of Q1. So if the distance between Q1 and Q2 is 0.2, and the distance between Q1 and P is 0.1, therefore the distance between Q2 and P is 0.1 also. Now we can start calculating. Calculate the electric field at point P located 0.1 meters to the right of Q1. Now, due to Q1, electric field strength is equals to K Q1 over R squared. Coulomb's constant is 9.0 times 10 to the power 9. Q1 is positive 3 times 10 to the power minus 6. And the distance R is 0.1 all squared. 9 times 10 to the power 9 times 3 times 10 to the power minus 6 equals to divide by 0.1 all squared will give us 2,7 times 10 to the power 6 Newton per coulomb. And the direction, as we have mentioned, is towards Q2. Now let's look due to Q2. E, which is the electric field due to Q2, is equal to, because I've already have KQ over R squared there, I can just start by substituting. So K is 9 times 10 to the power 9 times Q2 is minus 4 times 10 to the power minus 6 divided by 0.1 all squared. Right. If I've got a minus in my problem, before I do the numbers, I do the signs first. 9 times 10 to the power minus 9, this is positive. Positive times negative is negative. So anything squared will be positive. So my answer will be negative. So now I'm going to deal with the numbers first. Numbers only. 9 times 10 to the power 9 times 4 times 10 to the power minus 6 divided by 0.1 exponent 2. The answer will be minus 3.6 times 10 to the power 6 Newton per coulomb. Now, since I've got this 2 and they are both in the same direction, note this one means attraction, so it's also towards Q, as we have seen when we're dealing with the diagram only. So now I can add the 2 together, net electric field. E net is equal to electric field of Q1 plus electric field of Q2. Note, both of them are in the same direction, so they'll have the same sign. So E electric field according to Q1 is 2,7 times 10 to the power 6. Electric field of Q2 is 3,6 times 10 to the power 6. Adding the 2, they'll give us 6,3 times 10 to the power 6. Newton per coulomb towards Q2. Now let's look at the B part. Positive charge Q1. If the small positive charge of 1 nanocoulomb at point P, what force does it experience due to electric field? Question B, we are to calculate the force. So we know by definition the electric field strength is equal to the electrostatic force per charge. Let's substitute. We've calculated the electrostatic force, which is 6,3 times 10 to the power 6 is equal to the electrostatic force is unknown, divided by, we are given the charge as 1 times 10 to the power minus 9 nanocoulomb. So making the electrostatic force the subject of the formula, the electrostatic force will be equal to 6,3 times 10 to the power 6 times 1 times 10 to the power minus 9. So our answer will be 6,3 times 10 to the power minus 3 newtons. Note that the electrostatic force is in the direction of the electric field, and we determined that the electric field is towards charge Q2. So it's 6.3 times 10 to the power minus 3 newtons towards Q2.